Hello, I'm Evan Scheessele. I'm from Hewlett-Packard, and this Brownbag Tech Talk is just my sharing some stories about using Heat in HP Cloud, a major OpenStack deployment, and some lessons we learned in the operations domain. So really briefly, I'm in the printing side of HP. I'm not in the cloud business. My work is supporting a bunch of software and web service engineers who are deploying web services to support HP's printing business. So consumer printers that connect to the internet probably have some services connected to the web applications that I help support. And we've recently moved our web applications from Amazon into OpenStack on HP Cloud, the HP public cloud. And along the way, we learned a whole lot about Heat, and so I'm just sharing notes with you guys today. Again, to make sure anybody's orienting about this Heat talk, I am not a Heat expert in the super user domain, like as Jonathan was mentioning this morning, folks who operate clouds. I work with some great people in HP who operate clouds, and here's a talk from last year. Clint Byram, who's actually on stage right here this morning, he gave a great talk about using Heat to manage a cloud. Today I'm just sharing notes about how my team used Heat to run business applications on top of the cloud and how to be agile with our stacks and various applications in our portfolio. So again, Clint's talk last year was great about Heat managing the cloud. So this is where my work has been. With a lot of the talks today and a lot of the experts talking, it's a lot about deploying and managing cloud, optimizing clouds, using Heat, for instance. There was a great talk this morning about it. But my work is in the user domain, or HP recently I've read is calling this the execution environment. This is where business applications run. This is where solutions that you are hoping can be more agile on top of the cloud work. So that's where we found out we could use Heat in great depth to accelerate a lot of our work. Below that is all of the operators, or the super users as they were calling it. Those folks make possible what the stories I'm going to be telling. So we had a big project started a year ago to move several big applications, from our point of view in the printing world, large web service applications off of Amazon. Server count in the several hundreds, about 800 servers in one of our applications. And when we were picking up off of Amazon and moving into HP's own OpenStack world, we adopted some major principles here, right? These are familiar to a lot of folks in this world in cloud computing, but from a classic IT point of view, some of this is foreign. So I like to reemphasize this, right? Cattle, not pets. We're going to make sure everything is repeatable. Nothing is unique. We have the privilege of being able to bring up the same thing over and over again, destroy it, replace it. Big driving principles that led us to be using Heat. HP Cloud, there's a left coast and a right coast major public cloud deployments. It's actually two separate OpenStack deployments, but integrated at the control services, the keystone layer, so that as a business customer that I represent, basically, I have one relationship with HP's OpenStack public cloud, one domain. Many tenants, but one large domain in two different regions, and we had a lot of servers to stand up and reliably deploy. This is what my business applications stacks look like. It's a lot of fine reading. You don't have to, the big picture here is basically there's 4 vertical columns or 4 stack silos left to right. Each is a classic application, a web tier, an app tier, a database tier. And it takes basically one of these super stacks, 4 stacks lined up together to make one major business solution. We have a data tier based on Mongo with lots of disks. We've got just an Apache web tier and a bunch of Java Scala application code running in the middle. Together, one super stack, this is for one of our web service printing businesses, it's about 450 OpenStack resources, from virtual machines to Neutron ports to cinder block storage, load balancers or database, black box database as a service, and Trove-like objects. 450 things that you want to get right every time. And we have several of these. We have about 20 of these stacks that exist in different parts of the life cycle for this one application. So operationally, we knew the old way of doing things manually or using some shell scripts to automate stuff wasn't what we wanted. We were counting objects in the thousands. OpenStack had this thing called Heat, which back in the Grizzly timeframe 9 months ago was pretty young and sketchy, but we kind of adopted it wholesale and used it to kind of go after the infrastructure. So this is sort of our highest level automation model. The bottom here, we used Heat to automate all of our infrastructure deployments. HP has other tools, kind of heavier, more feature-rich infrastructure operations tools, but because we were adopting OpenStack in a kind of a deep, passionate way, we just put everything on Heat, and Heat turned out to be great at reliable infrastructure as code. Just JavaScript-based manifests that describe the topologies, back to these topologies. Pretty much every blue brick in here is a resource that is an OpenStack native resource, and we could turn that into JavaScript manifests that Heat deploys. On top of Heat, we use Puppet to do configuration management. That's that middle layer that kind of takes it from raw resources to configured applications. And then once you've got your configured servers, middleware applications, what you've got on top of that is end-to-end delivered business application. It's a quick snapshot at the kind of things that we did with Heat. Again, this is working at the user land, right, up in the execution domain. We made every part of our stack part of the Heat manifest. So we don't depend on pre-existing resources in OpenStack. As long as we have a domain and we have credentials, we could provision a Neutron router and the networking objects that attach to that, all the ports, all the virtual machines, all the block storage that boot or attaches data drives to the virtual machines. All of these pieces are part of our Heat manifest, and that allows us over and over again with one API call to the Heat servers that we built to produce those stacks. And it just hyper consistency, reliability, and usually within less than 10 minutes we could have new resources built up. And the most fun part about it, of course, is with Heat, you can also destroy things in extremely fast and efficient means. So as soon as we're done with the stack, one API call and the whole stack is torn down in the proper procedural way. What we aren't using in Heat yet in this application domain are some features that are emerging and definitely going to be exciting coming up. I still haven't found any real reason for us to use nested Heat templates. It's a feature. We'll learn more about it. Heat does a lot of software configuration tricks. It uses Cloud Init, or you can use Cloud Init inside of your environment. We don't use it at all, actually. We provision standard Ubuntu images. We don't even curate our own glance images. We just use standard Ubuntu, and the next step of our provisioning process, and back to this, the middle layer is to inject Puppet's agent onto our boxes and let Puppet pick up things from basic Ubuntu and install everything else. Heat stack update and the ability for Heat to start doing things like scaling and growing and changing the shape of our topologies. We're not doing it yet, but in the coming months we expect to, because it's a feature of Heat, and it's something we want to be able to do operationally is change the nature of our stacks. Here's where we are today. Our suite of business, our portfolio of applications in the printing side of HP, we have about 16,000 in-flight objects. Something we could never have done operationally just with kind of the old model of IT. Sure, most of that's security, but 1,300 instances and lots of block storage, lots of Neutron, lots of networking that basically is now just single-click provisioning. And then here are the lessons, the parts that kind of the meat of this last slide, and I can just take questions from anybody who's curious about Heat. With HP Cloud, at least, there's two regions. There's an East Coast and a West Coast. They're effectively different deployments of OpenStack. They're just glued at the control services, user experience, horizon level. So that means we have two Heat servers. Heat doesn't, at least as far as I'm aware today, doesn't support multiple deployments of OpenStack. So we have my own pet Heat server in East. We have my own pet separate Heat server in West. And my orchestration kind of front-end driving software just has to know which Heat server to use to deploy a stack in one region or the other. But of course, if you know how to deploy one Heat server, you can deploy an identical one with just a few tweaks for the other region. It was no major trouble. We learned a lot about Heat interacting with the underlying cloud can be unreliable at times. So I have deletes mentioned here. So deleting a stack can sometimes take up to 8 tries because the Heat server eventually runs into some impediment or an API call that returns an unexpected result. And so I have a stack that's halfway deleted. Half of its resources are still standing and Heat stopped. So we've had to kind of codify and learn to work around that and just basically tell heat, keep trying, keep deleting that stack until it ceases to exist. Heat logging is something I'm going to be talking, or at least paying attention to, at the Juno Design Summit on Wednesday. There's a lot of heat talk on Wednesday. It's not always transparent to me when heat gets an API error back from core OpenStack. Like heat's talking to Nova to provision a new server, and that doesn't go well. I get a 417 response. What does that mean? You know, the heat logging isn't always very rich, and it doesn't make it easy to try by hand the same calls that heat may have tried to learn maybe what's going on. So we've had to kind of inject some of our own additional logging and learn to work around that with understanding the underlying OpenStack APIs better, so that the heat experience, the heat interaction with them is something more familiar to us. Rates, that refers to rate limiting. Our first time that we used heat, we basically overran all of the rate limiting controls that HP Cloud has in front of their OpenStack. They don't want to be denial of service taken down. And our heat server was suddenly the most chattery thing going on inside of HP Cloud, as far as the support team told me at least. So we had to work with some really smart folks inside of HP who happened to be heat contributors, and inject some retry logic, some scale back, step back, pause logic, so that if I needed to deploy 50 Neutron ports and the Neutron API only lets you do 20 per minute, that the heat server doesn't give up an error, but instead it just backs off and it tries again, and so the script takes 5 minutes to run instead of 2 minutes. But API rate limiting is an issue. Heat isn't yet entirely perfect regarding API services that have rate controls on them. And the last one, quotas and limits. Just using heat in the business domain meant that we suddenly could stand up stacks faster than ever. We could give developers more utility, more tools, more reference copies of their software running on pet stacks, load test stacks. We could give them more faster, which meant there was higher demand, which meant we were provisioning more cloud resources into the developer domain, business development domain, than ever. And so we had to encounter all sorts of controls that OpenStack has. For my domain in this tenant, maybe I'm only allowed 16 gigs of RAM in this availability zone, or only 200 block storage devices, or only 1 terabyte of block storage, Cinder storage total. When you have these tools and you can automate things and you give developers self-service provisioning so they can get from ops, the resources they need, they use it, and we run out of resources. And there's a large kind of ongoing negotiation between the underlying cloud operators, the super users, and us in the application domain about how many servers we're allowed. And so basically, if you get addicted to using heat in the application domain, expect it'll get used, and you'll need to negotiate for higher limits and higher rates, quotas on resources. And that's the talk. Any questions? Yeah?
So I hate to say I don't know a lot about heat.
Neither do I. It's okay.
Last time I looked at the docs, and I couldn't find them.
Yeah.
But then you showed the things you weren't using, which are all the things I thought it did. So